Looks like it's 9 in the morning. Everybody seems to have recovered from jet lag or previous night or whatever you may have been up to. Thank you guys for joining me this morning. We're going to talk about .NET in a box, containerizing .NET. We're going to go through a lot of different things. Feel free to reach out and follow me on all the different platforms and socials. My name is Chris Ayers. I'm a senior customer engineer at Microsoft. And I'm actually part of an organization called CXP. We're inside of Azure Engineering, and I'm on the fast track for Azure team. So I help a lot of customers build and deploy applications to Azure, security, reliability, scalability, best practices. We follow a lot of the WAF pillars. So if you're building on Azure, definitely go check out the well-architected framework. There's a lot of great documentation there on how to configure services, how to build and deploy your applications through cost management, reliability, security, performance, and operational excellence. I've been part of teams that's written a lot of those guides, so it's really good information. Today, we're going to talk about some things. We'll start out with just general software and architecture. A lot of times when we talk about containerizing applications, scaling applications, you have to make sure your application can scale. That's something some people forget. And we'll talk about why. We'll go into containerization. Like I was telling people earlier, this is probably like the third .NET and containery talk here. So I'm following Hanselman, talking about some stuff. Hopefully, I can provide some different perspectives. We're going to specifically talk about .NET and containers. We got lots of demos to go through. We're going to talk about configuration of containers, some different methods we can use for that. We'll talk about security, a couple of different aspects as we layer it on. I've got pipelines we can talk about for GitHub and DevOps, and then we'll have questions. And if you have a question while we're going, feel free to raise your hand. I don't mind questions on the fly. So software. A lot of people, when they hear containers, they just instantly think microservices. They're like, we got to break it apart to a lot of loosely coupled services. We got to do all this modularity and things are going to be easier to test and deploy. And a lot of that is true. It also can add complexity for people that write monolithic applications. As long as your code is very well structured and modular, you don't always have to go to microservices and split things apart. But one reason you might want to go with microservices is if you have different parts of your application that need to scale independently, that have different security boundaries. Maybe your order processing system needs to scale and grow dramatically, but your front-end website doesn't. Like, you have options, and you can easily turn those dials with more control. Another thing you're going to hear a lot, as soon as you hear containers, a lot of people are going to go cloud native. Cloud native comes up a lot whenever you talk about containers. A lot of these applications are built on containers, they're built on PaaS services. So we've moved away in a lot of cases from cloud native, from using VMs, from using individual servers, to using platforms and services on demand at scale that let you do a lot of automation and manageability, infrastructure as code, platform engineering. These are things you hear a lot. Many cloud native applications do depend on containerization. So, one of the big things around containers is these are build and deployment patterns. When we are deploying containers, we are deploying them to scale. You don't usually run one instance of a container. You want to run 3, 4, 5, 10, 100, 1,000 instances of a container. And so when you think about things like that at scale, you start thinking about the software problems that come with it. You want to be able to isolate things, have repeatability and consistent testing. You want to be able to work with all those various cloud services and be able to know what's going on in your system. So it starts going into monitoring and observability. Open telemetry is a big topic that comes up when you're talking about these type of scales. Now, a lot of my customers I help move to containers. Maybe it's on app services, maybe it's AKS or Kubernetes or container apps. The first thing I have them do is understand their dependencies, especially if they're working in an on-prem or server-based environment. If they're doing file access, how files work in containers is a little different. I'll talk about that. Authentication, like some people on-prem are doing Windows off. And if you're doing a Linux container, your authentication systems might have to change, moving to more compliant standards like OIDC and OAuth. Understanding logging. If you're just writing text to a file, a lot of container applications will do standard out, or they'll use something like OpenTelemetry or an App Insights or Azure Monitor, something where you have observability into that platform other than just I wrote a log to a text file. There's a lot of OS dependent components sometimes. If you use certain libraries or device access and you're trying to do like PDF parsing, or you're trying to do special models that maybe use Windows libraries or use a certain property that's not available when you're in a container. That's something to very well be aware of. And sometimes you have to rewrite your application or isolate parts of it to support removing those dependencies. I'll talk about versions in a minute, but I'm going to talk about .NET versions. Another thing is, a lot of times containers try to be stateless. They handle the request, they can process it without any sort of context or information, go look up what they need to do and return the result. If you're having to do state, you have to maintain session, you have to look at ways. There are some options from load balancers to do sticky sessions, but managing session state in something like a Redis or some sort of remote session store is something that you might need to modify your application as you scale out. If you have 2 or 3 instances of an application and it's stateful and there's session and people bounce between them, they can start losing their session, losing their cart, seeing other people's information. And so if your application is not ready to scale and handle that type of traffic, putting lots of instances of a container out cause problems that you start seeing later on. So being very aware of those type of things, how you're handling state, how you're handling files, how you're handling databases. Now, I mentioned versions. I just like calling this out because I think it's important. This is the .NET support map. Let me go ahead and zoom in. We're right there in 24. The only ones that are currently supported are 6 and 7 and 8. 7 ends in May. Support for .NET 7 ends in May. Support for .NET 6 ends in November. So if you want continued security patches and updates and optimizations to the framework to make things faster and smaller, starting to look at moving to 8 is probably a priority if you're not doing that already. So just wanted to call that out. Some of the features I'm going to show today only work in 7 and 8. They will not work in 6 and before. So just something to be aware of. Now, I gave you a lot of things to watch out for when you're trying to containerize something. How do you find them? Sometimes it's trial and error. There is a project, there's a tool out there called AppCat, which is the Azure Migration and Code Assessment tool. There's a CLI version and a Visual Studio plugin that you can do. And you point it at your solution, it will actually scan through your dependencies and scan through your code. It'll do a static analysis. And if it identifies things like those weird file accesses or login, capabilities, or you're doing certain operations that maybe aren't compatible in a container or in the cloud, it will let you know and help prioritize them and call them out and where in the files you need to go fix them. So if you're like trying to run your applications, you start running into problems, AppCat can give you a nice report and give you prioritization. We're going to get into some demos real soon, guys. So I'm just trying to lay some theory down. Another really good tool is something called Dapper. Who's heard of Dapper? Cool. Who's using Dapper? A lot less hands. Okay. Who back in the day with like server farms and like new IPs did service discovery of some kind? How do you know what the IP or the address of your database is or your X service? You would have to do service discovery. How do you handle state? You would have to like point it at a file system or do a drive mapping. Or know about endpoints. And it might vary if you're doing Redis or a service bus or whatever. What Dapper does is it gives you all these great components that are reusable that kind of separate the implementation from the details. So as you say, I want a state store. You can be backed by something like Azure Blob. It can be backed by something from another cloud. It doesn't matter. The application code is kind of separated from the implementation of those backend things, and it kind of handles that. Same with like service discovery, same with like queues. There's all sorts of different components, as you can see in the image, like that you can leverage. And so it gives you these building blocks as you start looking at these containers and services. So let's actually talk a little bit deeper about containerization. Like I said, I know a number of people have talked about it already, but big difference between containers and VMs, this is something I like to show and talk about, is when you're running a VM, there's an operating system. There's a kernel there. There's all these libraries that are there. And you make a hypervisor. It's just a piece of software that pretends to be hardware. And so when you make a VM, you have a full virtualized hardware. You have a new OS on top of it. You have new libraries on top of it, new applications. So a lot of times these can be big. These can measure in gigabytes, which means when you spin up a scale set or you spin up a VM or you try to scale that way, it can take minutes for those VMs to be allocated because it's pulling gigs of data across. It's allocating compute to boot up the machine. Now you are kind of isolated from everything else because you're emulating hardware, so you're not sharing memory or anything, but it's much more intensive. But when we talk about containers, so containers, typically I talk about Linux containers. I'm not really going to talk about Windows containers. They exist. So Linux containers, they all kind of have evolved from some capabilities of the Linux kernel. We're going to get a little technical on some of these things. So the Linux kernel can set up like isolated namespaces and memory space. And so what's happening is when you run a container, they're sharing the same kernel. They're sharing the same memory. They're sharing the same access to hardware. All it's doing is setting up, it's almost like a CH root. It just kind of isolates it from everything else. And you're relying on the protections of the Linux kernel to keep things isolated using like these C groups and these namespaces. And so when your application boots up, it already has a kernel. It just needs the libraries and your application and configuration to be able to execute. And so when we do this, like we're getting images in megs. Like some Alpine and some really small distro-less images are single digits. Like if you do like a Go container, you can get down to like 8 or 9. There's some stuff we'll do today, get down to like 10 or 12 or 18 for .NET. But if you do some of the big SDKs that have all sorts of applications and debuggers and compilers in them, they might be 300 megs. So this is something we're going to talk about, like understanding image size and base images and how those are all built together. And as I mentioned, because it's a shared memory space, there is a little bit of security concern. There are people that are security researchers that have written articles about breaking out of containers, just like they've written articles about breaking out of VMs. It's a thing that can happen, but it's usually not something that happens in reality. The other great thing about containers is, and you might hear this topic, bin packing. So on a given server, you can have a lot more applications running in containers than VMs because you're not wasting all that space on another copy of an OS, on another copy of a library, on another copy of a kernel. So it's much more efficient resource usage. So when you hear about stuff like Kubernetes and thousands of nodes running tens of thousands of containers and pods, that's why a lot of large-scale organizations have moved to containers because they can scale. They're pulling a couple megs, they're spinning up a new instance, it's almost instant booting. So they can respond to traffic much more quickly than trying to spin up another VM. So let's talk about some of the terms of containers. Again, if you guys have heard this, please let me know to just move on and shut up. But the OCI, Open Container Initiative. Who's heard of Docker? Yeah, almost everybody. Docker is, who's heard of Kubernetes? Yeah. So Kubernetes for a long time used Docker. But then, because Docker had some closed source pieces, they started to adopt something like the OCI. We wanted a standard and a spec to define how you pull images, how you run images, like a standard way that people could go and implement a new container runtime, implement a new container image system, however they wanted, because they were following a standard and a spec. Docker donated some code. There was a lot of stuff that went down. I'll talk about it a little bit, but OCI is the project that kind of owns the specifications for containers. So how to pull images. And so a lot of times you'll talk about OCI images. So Open Container Initiative compliant container images. So if you see OCI, it's just the standard spec. It's the same as a Docker image, that they both implement the same standard. So images use a layered file system. And so each slice is immutable. It gets a hash. You can actually extract them out as like tar files, or kind of like zip files. That's just a collection of files. And what happens is it'll layer them into a directory and mount that as the file system. What's great is each layer can be independently cached and reused. So if you're building a brand new image or pulling down a brand new image, it might pull down a couple hundred megs. But if you spin up another image and it can reuse all of those shared layers, like the operating system base layer, stuff like that, it might only need to pull down an extra 5 megs to get your specific application libraries or something. So it's going to, overall, it's going to use a lot less storage space because it's reusing a lot of layers. One example of this might be if I'm using the same type of Docker image to build .NET. I'm building 2 or 3 different applications. It's not going to need to pull down a copy of an OS and all this other stuff every single time. It's just going to use some very base images of libraries and dependencies and .NET, and it can reuse those multiple times. And the only change is going to be my application layer on top. So when I push those out to images, to repositories, container registries, it might only push a couple megs at a time because those other layers are already out there, they're already cached and already reusable. So you get much faster updates as well. Another thing about images is you can tag them, which is like versioning. And you might hear people call them stable and unstable tags or stable and unique tags. There's actually some security implications for both of these, especially if you're scaling to lots of images. And I'm going to show you as we get into it. But like stable tags, if I just say latest and I pulled down an image today, I might get some collection of bits that is the latest today. If I do it again tomorrow, I might get a different collection of bits. So if I have an application where I just said use the latest image and I scale it out, I can start having one set of nodes run with an older version and a different set of nodes run with a newer version and run into some weird problems. So that's where unique tags come in. You might key them to the commit hash of your repo, your Git repo. You might key them to a build number or a very specific date and version number. That way you don't want it to change every time you pull it. As you scale out, you want to always get the same collection of images and layers. Now, a lot of times you might use a stable image you might use it for a base image. If I say I want to get the latest Ubuntu, I want the one with all the latest patches and stuff as I'm building on top of it. That way I can version my new one with all the latest fixes. There's a lot of debate on like when to use stable, when to use unique or unstable, but I usually go with stable for base images. That's how I kind of consume them. And then I build my stuff on top. If I need to have complete SBOM, like software bill of materials, like reproducibility, I'll use a stable or a unique tag at both the OS layer and the app layer, but we'll talk about that in just a sec. So I talked about all these images. We use registries to store them. There's a bunch out there. These have version control, these have access control, these can do security scanning. You can integrate with your CI/CD pipelines, which I'll show you. Up there, I've got the Azure Container Registry, Docker Hub is one, GitHub has a registry. And then that bottom one's called Harbor. You can actually run that in your clusters. It's an open source container registry. There's also runtimes. Runtimes are the things that actually run your containers. And they have high level and low level runtimes. So like Kubernetes might talk to the high level runtime, and then that'll push out to the nodes. And then on the individual nodes, there might be a low level runtime that does the actual starting and stopping and all that. I only mention these just so that you get familiar with the names if you see them, like Containerd or Cryo or runc. And this is how they're all kind of connected. Kubernetes has this container runtime interface, CRI. They used to maintain it for Docker for a while, and then they were like, hey, Docker, come fix your own stuff. We're tired of it. And they didn't really, so they just kind of moved on to do their own thing, which is why Docker is not an official runtime for Kubernetes anymore. But you can see how everybody pretty much falls through the OCI spec down to some runner that runs the actual containers. So let's start running some containers. Let's start building some. One reason I do them in .NET a lot is portability. If you've been running .NET Framework on Windows, you're stuck on Windows. If you're doing .NET Core, .NET 5, 6, 7, 8, Mac, Windows, Linux, it really doesn't matter the platform. You're going to have a consistent runtime no matter what. Like it's always going to run and behave the exact same way if you're using containers. And it's a lot easier to scale. Everything's very isolated. You're not worrying about file system changes or registry settings. By default, they're very secure and they're very resource efficient. Microsoft puts out a bunch of container images. They've been doing it for about 10 years. There's one for SDK. So if you want to build, you can use a special image that has all the SDK tools. You don't want to run that in production. You don't want to give hackers access to tools to recompile stuff. So you use that in development or in your pipeline to compile your applications. And then you can copy out the bits that got compiled and use something like an ASP or a runtime image that just has the bits you need to execute ASP code or .NET code. And so this is the idea behind multi-stage Docker files, which we're going to talk about. Who's familiar with Docker files? Who uses them, loves them, hates them? Yeah. So Docker files have all the steps to build your images, where you pick your base image, how you expose ports, how you compile and copy files. I recommend making sure you have a Docker ignore file, and I'm a big fan of multi-stage builds. The order your steps are actually can influence caching. So for instance, if you copy over your app code and nothing really changed, cool. If you do a restore and like one of the dependencies updated, your app code might already be cached and it just needs to make a new layer for restore and new layers for build. So like if you, depending upon the order, you can improve caching and make things a lot faster and regularly rebuild things so that you can get security issues. So this is a Docker file, just as an example before we start running them. So you can see at the top, we're pulling from mcr.microsoft.com. So that's the Microsoft Container Registry. It has all of the images that Microsoft puts out. And we're actually doing two stages. So the top part, we're getting the SDK. And we're going to build our code. We copy it over from our current directory. We do a restore. We do a publish. And then we make a new container for the runtime with ASP. And we copy from our build image to our new image, the app out folder. And we define how we start our application. I'm just saying .NET blah. So this is a very basic, kind of standard Docker file. They're okay. There's also some new capabilities, which I'm going to show you guys, where you don't even need to write Docker files anymore. This only works with .NET 7 and .NET 8, where you can just actually pass a flag to say publish container. And it will build a container without a Docker file. You can even push it to a registry. And we're going to talk about some of the cool features where you can actually pick container families. If you want to do something like Alpine, which is a smaller distribution than Ubuntu, and then there's some additional options we can do. And another thing I'll show you is AZD. So if you're trying to do .NET and you want to containerize your app and you're not sure how to write that Docker file or how to create the Azure infrastructure, AZD is the Azure Developer CLI. It can actually scan your code, say, hey, I found some services. Do you want me to run them as container apps? You want me to run them on Kubernetes? You want me to run them as a function? Do you need Redis? And it'll build the infrastructure for you and deploy the code. So it's a way that you can get started. And I'll show you guys that. And then, of course, Fowler and Edwards last year too had a workshop and have had some sessions on .NET Aspire, which is a preview thing with .NET 8. It is a really new opinionated way of making cloud native .NET applications, and it's all container-based stuff. So there are a lot of options to get you started. Let's go play. Not enough slides. Sorry about that. So here's our Dockerfile. I can .NET build, and I can give it a tag like sample API, and just build. I'll just do this. Sorry. Got too many commands to remember sometimes. And so I had already built it previously. So remember I said Docker caches the layers and remembers what's there. Because I had already built an image and I had already pulled down .NET, like it instantly, 0.0 seconds. Oh wait, there was a 0.3 there where it loaded the information. So it's loading all the different layers. And then every single command inside my Dockerfile makes a new layer, like we talked about. So that work dir, where it's setting my directory, where it's copying over my files, it's running restore. Now, if I go and make a change, let's say I just come in here and change my file and do it again, you'll see it's now doing the restore. It's reusing all those cache layers, and it's just doing the restore and build because it detected that something changed on one of the layers as I was doing the build. I've got an image now. Cool. What do I do with it? So we can run it. Now, this is where things get a little more interesting. Usually when you get into Docker files and containerization and Kubernetes, the bane of most people's existence is networking. Who loves networking? 2 people, 3 people. Most problems are always networking, or DNS, or caching, which is kind of networking. Anyways, when you run applications, a lot of times they might expose a port, when you're going to access the application. In Docker, sometimes you have to map those ports and say, hey, I know the container is listing on 8080. So if I just do .NET run, so I'm not doing it in a container, I'm just doing something locally, it's compiling, it's building. It's listing on 5133 or 5134, and I can environment. So I'm on Bullseye, I'm running in WSL, and my current user is VS Code because I'm in a dev container. Cool. So I can stop that. Now, if I want to run the Docker image, there's a couple of commands here. I'm doing Docker run. I'm saying IT, so interactive terminal. I'm saying -rm, remove it when I'm done. And then, hey, map port 8080 from my local computer into port 8080 inside the container. This is called a port mapping. And then use the tag sample API latest. That's the one that got built when I did my Dockerfile. And so if I go to my browser, this is on Linux 12 Bookworm. It's a different OS version. It's using the same kernel, but it's using a different distro because I built it off of the sample thing. And it's a different user. So it's kind of its own complete thing. It's running as a different user. It's running on a different OS. And I can change this port mapping if I want. So I started it on port 8080. The .NET 8 images by default will listen on port 8080. So maybe I want it to listen on port 9000 locally, and I want it to redirect to me to port 8080. I can do that. So I'm still in the same image. Now I'm on port 9000. So the container runtime and the systems around the container provide that configuration, provide that mapping of ports. And I'm always getting the same thing. I'm just wiring it up slightly different every time. That's one of the ideas behind containers. Don't need to ship my laptop, I must ship the container. And because the files are immutable, pretty much every time I run it, I'm getting a fresh copy of exactly what I containerized. All right, so we got that container. Cool. We got the Dockerfile. I mentioned you can do containerization without a Dockerfile. So here is a different project. Let me just show you. There's no Dockerfile over here. I'm just going to print out some of that same information. And what I can do is .NET publish /t publish container. And .NET is going to automatically kind of figure out what I want. And so it's using the .NET runtime 8.0. Like I didn't really tell it anything, and it pushed hello containers latest to my local Docker. So see, I can run my image as a container. I didn't do any Docker files. I didn't do any writing. Okay, cool. Well, some of the other things that they baked in, which is really neat, is you can change your container tags and you can change your base image. So this time I'm telling it I want to tag it Alpine. So it's going to give it an extra tag called Alpine. And it's going to use a container family called Alpine. So when it's doing its build, it's going to try to use the Alpine build. When it tries to do the runtime, it'll try to do Alpine. And if you look right here, runtime 8.0 Alpine. It switched the base image based on a little command line flag I gave it. A lot of people use, who's heard of Alpine? That it isn't really in the, okay. So Alpine tries to strip away as much stuff as you can and get really small. And one thing they do is they actually don't use libc or glibc, which is the very standard C library. They use a different implementation of a C library called muslc. And so it has some small incompatibilities for some applications. So not everyone likes using Alpine. Sometimes they do, but sometimes they try to use Ubuntu or something smaller. Problem with Ubuntu is it has all this extra crap with it. It's got bash shell, it's got curl and wget. And so you have all these vulnerabilities. If somebody can break out of your application and cause a problem, they might be able to get root or access to a shell and then download additional things. It can be a security problem. So Alpine is a great way to help reduce that landscape. Well, the other thing that has come out with .NET 8 is there's been some partnerships with Ubuntu. And Ubuntu has been pushing the idea of these chiseled images, which are kind of like distroless. And the idea of distroless is it doesn't have all that extra stuff. Might not have apt, might not have a bash shell or wget or curl or all those extra things. So it's going to have a lot less dependencies. And .NET has worked with them to make like just the runtime dependencies that's needed to make .NET run. So they've tried to reduce the image sizes really, really small. And so I just built this one. This is based on Jamie chiseled. And if we look at Docker images, we've got 3 images here. We got the original one I built with just publish. We've got the Alpine one and the chiseled one. And I don't know if you noticed, we cut it in half. So just the base, like build it, maybe it could be a little insecure, but because it's based on a full OS, it's based on Ubuntu. But we can reduce that down. So now at 80 megs, that means it has my application, it has all of the .NET runtime that it needs to execute my application. And so when I'm trying to scale my image, instead of pulling, a couple gigs for an OS, I'm only pulling like 80 megs to create a new application. And on today's infrastructure, that's crazy fast. Now, something else to be aware of that they've been working on and some of the .NET 8 stuff is, and let me just show you this. This is kind of cool. If this runs, I might have pasted it weird. So, and Corey makes a tool where you can look at packages and stuff inside of image files. So in the runtime for .NET, there's 168 packages installed that are .NET specific. If we look at like Debian packages that are installed in the runtime image, and this is just the base like runtime. Like you're not trying to optimize for size or space, there's 92 packages. So when you're thinking about security, when you're thinking about trying to minimize those, entry points into your system, that's, 250 or so. Now, if we look at some of those smaller images, like that chiseled one I talked about, and by the way, Alpine is just an open source kind of community supported thing. The Alpine or the Ubuntu chiseled stuff actually has like a support contract, and like Microsoft and Ubuntu are supporting it for a number of years. So there's some like long-term support on these type of images. So there's still those .NET packages, but if we look at the .NET or the Debian dependencies that are inside that image, it goes down dramatically from 92 to 7. So there's only 7 actual packages installed in that besides .NET. So it's a much smaller attack surface. Base files, certificates, libc, and SSL, and a couple of other things. So when you're trying to think about building these containers, we can do some really interesting things trying to keep them small. Now, I kept mentioning, it's got shells. Yep. You can change an entry point into a Dockerfile. So when you have your Dockerfile and you're like, hey, my entry point is going to be .NET. When you spin up my container, run .NET, you can actually give it a command line argument. Don't do that. Instead, give me bash. Let me do a command line. Let me play around with it. So the base image where we were just based on Ubuntu has a shell. I can look around. It's got apt. It's got tools installed potentially, or I can go get more tools. But you can also see it's not running as root. It's running as app. So they've started changing a lot of the base images with .NET to not run as root so that you're not just getting full access to the system. It's a little bit reduced and it's a little bit more secure. If I try doing this with the chiseled image, it actually gives me an error because there's no shell in that chiseled image. So they've removed a lot of those tools that would let you be able to get in there and poke around and let you be a lot smaller attack surface. So a lot of that work, that chiseled, the Alpine work, was because the .NET team and Microsoft have been getting feedback for 10 years on the container images they put out. People kept saying, we want them smaller. We want them faster. We want them more secure, like get rid of root. We want non-root by default. Minimal dependencies. They even have some packages where it doesn't include localization. So if you're not doing global localization, you can remove those packages, make it even smaller, and then you can add them back in if you need them. So you can do localization. The Ubuntu chiseled uses the glibc versus Alpine's muslc libc, and they have support from both Ubuntu and Microsoft. And so, as you saw, going from a full like Ubuntu jammy down to chiseled, you can get a lot of size reduction. And .NET 7 and 8 actually added a bunch of other capabilities you can add on top of that, which I'm not really going to go into, but you can do trimming. You can do AOT compilation, so you can actually compile it down to like native code for like x86 and actually bring it down to like single digits if you want. So if you're trying to get super small, super fast, super scalable, you can keep tweaking stuff and get a lot smaller if you want. And so this is what I was talking about. Like when you have some base images, you've got your base OS, you've got additional runtime dependencies and the runtime and the SDK, and it can get big. So when you start doing chiseled, like you can really get a lot smaller, as we saw, like around 80 gigs or 80 megs, running as a different user. Now you can, if you want, you can override the user if you need to. So we were seeing that this one is running as app, so I can pass minus user root, and I can put it back. There are some weird behaviors that some people report, like in your application, like if you're trying to do certain things with files or you're trying to do certain accesses, if it expected root and you're now running as a non-root user, and it blows up, you can put it back. So that's not that big of a deal. Next, I want to, and I will bring up CI/CD. We will go look at pipelines. We still got plenty of time. But I want to talk about configuration. So there's a couple ways to configure things. I do a talk on .NET configuration. So when you went from Framework to .NET Core 6, 7, 8, they completely revamped the configuration system. It uses configuration sources and configuration providers, and it unifies everything into a configuration. This can come from environment variables, those app settings JSON. There's libraries you can plug in for Azure App Config. You can do Key Vault. You have all sorts of capabilities to pass things. When we're talking about cloud native applications, stuff running in Docker, stuff running in Kubernetes, a lot of times you're going to pass environment variables in your spec files. So, these are the easy peasy, like you can just add environment variables. I'm not a big fan of doing a lot of stuff with environment variables. I'll do as little as possible to configure it. So if that means pointing it at an app config endpoint or pointing it at a host that it can then do additional stuff, cool. I try not to use secrets whenever possible. So with modern cloud platforms like AKS, with container apps, with app service, you can do managed identities. So you can have explicit like RBAC rules in federation where you say this workload, this set of containers, this app is allowed to talk to this database and read only, or it can make inserts and updates, or it can read this file system. So you don't need connection strings with secrets. It's more about you set up the host to have an identity and allow that identity to have access. So I hate this example, but it's an example I've seen where you have, hey, here's my environment. I'm going to have a connection string. And so when the application starts up, that environment will be injected into, like that'll be part of the container. And so when the application starts up, it'll see that, load it into the configuration and be able to access it. I don't like that, but that's what a lot of people do. When you're doing Kubernetes, you define your image and maybe you put some environment variables there. Again, some non-secret stuff like this, yeah, I prefer using Azure App Config because I can just give it a host for Azure App Config and the identity will let it authenticate. And then I can have all of my non-secret stuff accessible there. And that lets me do feature flags and feature toggles, and .NET supports hot reload on that configuration stuff. So you can do a feature flag and .NET will just pick it up and respond to the change without having to restart and reload your containers. Another thing that you can do is app config can have key vault back secrets, so you can do all that. But when we're dealing with Kubernetes, a lot of times we use something called the CSI secret store driver. And you can use Azure Key Vault as a backing store for that, which means all your secrets are in Key Vault and they get mounted into Kubernetes kind of as a file system, and .NET can pick up on that and use those secrets. And so that's where you can put certificates and secret files and connection strings and passwords and all the things that you don't want pasted as a text string into a Kubernetes manifest. Base 64 encoded as a secret. Yeah. So Kubernetes secrets are just base 64 encoded. They're really hard to crack. Yeah. Don't do that. Don't use them. So the secret store is really good. It'll automatically mount the stuff when you have it configured right. You can use managed identities to back it by Key Vault, and it makes things a lot easier. So that's how I do a lot of secrets. And there's good documentation. I mean, I'll pull it up momentarily. So let me just do that. So if I just look up CSI, if I can type secret store. See, Kubernetes CSI secret store driver. And there's lots of documentation on using it and providers. And we have, different providers that you can leverage and all sorts of stuff you can do with it. So that is what I would recommend. And all right, so security. Yeah. They support managed identities, and you can connect them out to Key Vault. I I got to double check on the secret store. I don't think so. They do support Dapper for a lot of stuff, and you can use Dapper to securely get connect to the secret store, though. Yeah. So I'm going to show you in the pipelines, but you can run a lot of scanning on your container images. Now, this will scan both the base images. It'll scan the layers. It'll see if there's a CVE or a vulnerability in there. Microsoft has Defender for container registries and Defender for containers. We also have that uses Qualsys, but there's also a lot of providers out there that do security scanning. Sneak, Trivy, even Docker Scan can tell you if you're using insecure base images that have vulnerabilities in like wget or in a C library or libSSL. And so I incorporate those into my pipelines to scan before I push up to the cloud. Yeah, I already went through the users. So let me go out to the pipelines and show you what I'm talking about. Yep. So this is my GitHub for this talk. And so a couple things. First, I'm using Dependabot. So if you're on GitHub, set up Dependabot. It can scan your Docker files. It can scan your .NET code. It can tell you if you're using older libraries and submit PRs against them. It can also scan your GitHub workflows and tell you if your GitHub actions are out of date and submit PRs against your GitHub workflows so that you're using the latest tasks. So I made a couple of workflows here. First one, this actually came from, part of it came from GitHub, because you can say, I want a new container workflow, and it'll do stuff like this, where it'll install cosign, so it can actually sign your container images, like with a hash. And then it sets up BuildX. So who has a Mac? M1 Mac. Who had problems with containers or Python or certain languages with an M1 Mac? Yeah, so architectures are a big thing. A lot of container systems in the cloud assume you're running x86. But if you're trying to build images locally, like with ARM64, like off of a Mac, you couldn't really push it and have it execute up to the cloud. It was a pain in the butt. And so it was also hard sometimes to compile x86 code on an ARM or ARM code on an x86. Docker BuildX will let you do those cross-compile and let you like build images for other architectures very easily. And there's a task called Docker logon action. You can use this to log on to Docker Hub, Azure Container Registry, AWS, Google, GitHub, whatever. It sets all the Docker context you need. And so I have, from ACR, I have the ACR name, which is my Docker login server, and my authentication to log in. And I can just use something like build push. And this will actually build my image and push it up to the registry for me as part of my pipeline. But I told it, I don't want you to push. I just want you to build it locally because I want to run some tests before we push it to the cloud. So you can do like a build, do some tests and scanning on the build agent or locally, and then push it up only if it passes your criteria of quality. So I'm running Trivy. So Trivy is a tool from Aqua Security. They have a lot of great stuff against like Terraform and Bicep and Kubernetes, but it can do file system scanning and image scanning. And so I told it, hey, go scan the image that you just built. And then if everything is good, push it up to ACR. And if it's prod, you can sign it. So you have a lot of capabilities you can do pointing at like a Dockerfile. We also talked about those new .NET capabilities. So I can just actually check out my code, set up caching, log into Docker, and do that .NET publish and tell it, go publish to this registry. Give it this tag. And so if we want to see those run, let's start with the Docker image. Looks like I broke something at some point. We'll find out. But these are all pretty standard images. You can see it's building and extracting and built my image. A lot of it was cached, it looks like. You can see it loading the different layers and stuff. Now it's running a Trivy scan. So Trivy downloads a database of vulnerabilities. So it was like downloading that. And it says it was detecting vulnerabilities, and it kind of has a JSON array where it's telling you like, hey, maybe this package should be updated or this package. So it's giving you all that information. And it actually will load this into the dependency graph inside of GitHub. Let me get down to the last step. So now it's pushing it up to the cloud. So it pushed up my image. So this went out to my ACR, sample main, and if I go out to Azure, here is my Azure container registry. And it just pushed one a couple seconds ago. So my pipeline can do that. And when I'm building Docker, I can do that locally. But there's some other capabilities I have. Now, not everyone has Docker installed locally. Sometimes you might want to just have a different host build it for you. ACR does have the capability to, am I in the right folder? I'm in the wrong folder. It can actually build stuff for you. So if you're like trying to get started in a container and your machine doesn't have Docker, you're not allowed to use Docker, and you're trying to build it, you can actually have ACR build it for you, the Azure Container Registry, and then you can set up ACR tasks where it'll automatically monitor your GitHub repo or your DevOps repo and just build your images if it detects a base image update. So if like Ubuntu got updated, it would just rebuild your image if you wanted it to. Or if you made a code change, it could rebuild your images, and then it'll run security scans inside of it. So it's zipping and uploading my stuff, and it's going to build it in ACR. So that's like a pipeline for GitHub. Let me bring up a pipeline for Azure DevOps just to show a sample. This comes up. There we go. So here's an ACA demo, actually. And you can do some really interesting things with DevOps pipelines. You can pass connection strings as parameters. You can pass variable groups as parameters and tags. So I have a template here to build Docker, where I'm going to give it the path to my Dockerfile. I'm going to give it the name of the ACR and like my connection string. These kind of got to be hard-coded at the top level for approvals. But once that happens, you can use it inside of a template. So this has just almost like the other ones. I've got a Docker build task, and I can just give it the connection string, the name of the image repo. So I'm using sample API. That's the name of my image. And I'm giving it some tags like latest or main. And so all of this just automatically can build. I can tell it if I want to do a Trivy scan in there, and then I can push it up to my ACR. So you have all these capabilities to, if you can do it on the command line, you can easily do it in GitHub. You can easily do it in Azure DevOps to build those images and push them. And we got about 5 minutes left if anybody has some questions. But yeah, so there's that one I did from the command line. You can see I have a hash. I can, something else I should point out that I like doing is there's a Docker extension for Visual Studio Code if you haven't been playing with that. And you can actually come in and you can see your images. You can, inspect your containers. You can run your containers. You can, you get information about your Docker files. You can build Docker files just by like right-clicking on them. So build image. So there's some really cool capabilities in that. You can connect to your container registries, and you can see the different versions. You can run containers and interact with them. So the Docker extension of Visual Studio Code is really good. And then if you're building new projects in Visual Studio 2022, and I think this goes back to 2019 and maybe 2017, if you create a new project and you're like, I want an ASP project, again, sorry for the font, I'll try to zoom it in a second. So I'm going to do a web API here. Next. It doesn't zoom, so let's try this. Yeah. Enable Docker. You can just check the box. It'll make Docker files for you there. Yes, they exist. So you can just check that box, and it's pretty cool. So with that, let me zoom back out for one. There we go. Questions, comments, anybody? Yes, sir. One of the big, the question was, when you pick Alpine or Chisel, is there any reason to use one over the other? The big reason between them is that base C library that Alpine is built around, Musel C, versus glibc, which is in Ubuntu and most common Linux distributions. There's some small incompatibilities. So if you're pulling lots of libraries and doing lots of third-party dependencies, you can get weird behavior sometimes in Alpine. And there's a reason that some people fall back to like using a full-blown Ubuntu, but that has other security problems. So Chiseled is kind of a good middle ground.
But then, like, if Chiseled is the same size, I don't really see any point to using Alpine.
Good point.
Yeah.
I wonder why I showed Chiseled.
Mm-hmm. Cool.
Other questions? We got one over there in the back.
Hey, when .NET announced the chiseled images, we looked into it to see if we can use it. But one thing we kept running into is Docker container health checks. So because it's so chiseled, we couldn't really figure out a way of how to do health checks.
Oh, I have some health checks.
ECS, we really need those health checks.
Yeah, so in mine, I actually added health checks. I just added a really simple predicate to say it was ready or not ready. So if I were to go back and publish this one in Chiseled, and I'll run it. But I have both readiness and liveness probes. So one thing that's really important in containers, especially Kubernetes and scalable systems, having these probes that tell you if the container is ready or if it's live. So what that means is, as it's spinning up, you don't want to start sending traffic to a bad node or a node that's initializing. So the system will check these endpoints to see if it's ready. And so by leveraging those, let me minimize that one. Let me bring this one up, and let me just run this guy real quick. There we go. Port 9000, open browser. So I can say, hey, are you ready? It should say, good. Are you live? Oh. Anyways, you can set them up with health checks using that stuff. I didn't run into problems when I was doing it, but it might depend on the complexity of the health check you're trying to do.
Yeah, for us, the health check, it's the actual Docker health check. So
you're actually hitting Docker.
Yeah, so ECS kind of means that because it looks at that to figure out whether your service is unhealthy and whether to redeploy a new version.
So you're not actually hitting your application endpoint. You're actually you're interrogating the Docker runtime.
Yeah,
that's what Kubernetes does, and that's what Docker Compose does. So seems complex. That's why people have endpoints on their apps. Just saying. If live says false or not respond, then you just assume it's dead and kill it. So, other questions? We got one up here.
You had a lot of shared projects.
Oh.
I had to basically, in my build pipeline, for every makefile, for every one of my projects, keep on copying the same shared projects.
That is, okay, so the question around that, I'm actually going to go to a different project because I had somebody who asked me this, and this is more of just a DevOps-y type question that applies to GitHub or DevOps or mono repos versus multi-repos is, let's say you have a project with multiple web endpoints or something inside of there, and you have one big solution that you use. Was this the scenario you're talking about?
Correct.
Never heard it before. So maybe I actually want to set up a different repo that has all of my shared templates, something like this, where I can reuse these across all of my projects. And then in this project, you're right, you do have to do something stupid and annoying where, per project, you're just passing in like a build config that says only build this one thing and only publish this one thing. Because if you do a .NET publish, it will publish all of the endpoints and all of the projects, and you want to only publish one. So there's ways around it. It's annoying.
Does the .NET 7 and 8 tooling with that?
It's just kind of an inherent thing with solutions and CSproj files. Like when you say publish, like in the Zippo web project, it's not super intelligent sometimes.
I was mainly just doing it to get an efficient build of multiple projects.
Use build configurations and tell certain projects not to build, make multiple ones, and then you can do what I did, which is like pass that stuff in the templates. And that way you minimize the reuse, and how I build, how I test, how I validate, how I security scan is all isolated in this one template. And so when I have an improvement or a change in my process, everybody benefits.
Thank you.
Yep. Any other questions? We're probably like a minute or two over, but all right. Well, can I get a selfie with you guys before you go? Is that all right? It's my first time here in Australia. I figure I might as well make it count. Everybody say hi. Thank you guys. I really appreciate you coming. Don't forget to put the greens in the box on your